The steam developed in the waste heat boiler is used for the production of electricity and district heat. The steam drives a turbine and thus generates mechanical energy that is furthermore converted to electrical energy in a generator. This is then fed into the public electricity network. Hence, 25,000 Viennese households can be supplied with electricity. The steam taken from the turbine is used for the generation of district heat. It condenses to water in a heat exchanger and delivers its heat energy to the district heating network of the city of Vienna. This energy covers the heat demand of 50,000 homes. By using the heat energy that develops due to the thermal handling of the waste, the degree of efficiency is 76%. Parallel to the extraction of energy, the fight with the flue gases starts now. This fight lasts for 4 rounds. First of all, there is the electrostatic precipitator. It is used for the removal of dust. In round 2, the toxic acids are rinsed out of the flue gas in a 2-stage scrubber. Round 3 starts with the active coke filter for the separation of organic toxics. The 4th and last round takes place in the catalyzer, where the nitrogen oxides are removed. But let's have a look at this now in detail. Let the fight begin.
Round 1. The electrostatic precipitator. The flue gas coming out of the waste heat boiler reaches the electrostatic precipitator. Here, plates and frames are alternately mounted. Emission electrodes under high tension are placed in the frames. The flue gas flows through the electrostatic precipitator, and the dust particles floating in the gas are electrically charged by the emission electrodes. Under the influence of a high-voltage electric field, the negatively charged particles of dust are attracted to the positively charged plates, the so-called precipitation electrodes. In order to clean, the plates are made to swing mechanically, whereby the dust falls into the collecting funnels underneath the electrostatic precipitator and is transported from there to the ash silo. After further treatment, the ash is also deposited together with the slag on the city's dump site. Round 2. The wet scrubbers. Time for a shower. The basic procedure in this cleaning round is the rinsing of toxics with water and lime milk. In the first scrubber, water is sprayed in by jets. In the process, chlorine and fluorine compounds, but also heavy metals, are washed out of the flue gas. In the second scrubber, lime milk is sprayed in instead of water in order to separate the sulfur dioxide. The lime milk reacts with the sulfur dioxide to a gypsum suspension that is continually extracted from the scrubber. The washing water is cleaned by the plant's wastewater treatment and then subsequently fed to the main wastewater treatment plant in Vienna. The solids that remain after the wastewater treatment are the so-called filter cake and gypsum. The filter cake is deposited underground. Gypsum can be processed for use in industry. Round 3. The activated coke filter. Off to the coke chamber. The cleaning principle of the active coke filter is very simple. The flue gas flows through several layers of special brown coal cokes, and the toxics can accumulate on them. The coke used has a multitude of fine pores with a surface of 300 to 400 square meters per gram. This is equal to the size of about 1.5 tennis courts. This fine pore system is especially suitable for the adsorption of gaseous toxics and very fine dust particles. Because the adsorbency of the active coke is depleted after a while, the used active coke is continually replaced by fresh coke. The used coke is incinerated. Round 4. The Denox unit. Now fast reaction is necessary. Unwanted nitrogen oxides are removed here. Before entering the Denox complex, the flue gas is sent once again through a heat exchanger and heated to a temperature of 180 degrees centigrade. Now ammonia water is added to the flue gas by means of jets. After mixing well, it moves on to the catalyzers. These cubes, made of porous ceramic, have a multitude of thin channels through which the flue gas can flow. On the surface of the catalyzer, optimal conditions prevail for the chemical reaction that allows the mixture of nitrogen oxides and ammonia water to become harmless nitrogen and water vapor.
At this stage, the flue gas cleaning is completed, and the pure gas is dispersed via the chimney at a height of 80 meters. The clean combustion air that leaves the plant is put through a stringent test. Samples are taken at 2 test points in the chimney, so the quality of the flue gas cleaning can be continually checked, and the result is not bad at all. The new MVAPFAFFENAU is 90% lower than the allowed limit for dust exposure. The MVAPFAFFENAU is therefore another substantial contribution to extending Vienna's leading position in protecting the environment. All right?
Responsible handling of the waste that we all produce every day. The city of Vienna stands for this, and the MVAPFAFFENAU is the best example. High tech for the environment, so the high quality of life in Vienna is preserved for generations to come. Vienna is one of the most beautiful and cleanest cities in the world and extracts energy from non-recyclable waste.